This is a little foldable. We're going to add some notes to it, and then you can just, if you have a notebook, you can staple it in there, or you'll notice the back is blank, so you can glue it in there. So you can open it up and look at the features of the 4 different conic sections. We're going to add some information that's appropriate for it, right? Okay, so let's start with circles. All right. You open it up to your circles. What? Oh, okay. When you have your equation, we're going to write it right here underneath the circle. It's x minus h, quantity squared, plus y minus k, quantity squared, equals r squared, where r is the what? The radius. So we'll put a little r right there to show that that's a radius. And up here next to radius, we'll put another r. And where's your center going to be with that equation? HK. All right. This stuff on the right side of the flap is a little more than what we're learning in Algebra 2. Just know that as you start moving into pre-calculus and calculus, it's going to get a little more detailed. Okay, so for right now, we're focusing on where's the center, what's the radius, how to get it into this form, and how to graph it. Okay, so if you can do those things with the circle, then you're in a good spot. All right, so let's move on to parabola. All right. The parabola on the left, the one that opens to the right, or it might possibly open to the left, you're not going to see this till you get to pre-cal, although I think in the book it showed a couple, and it even had you look at, well, where is the directrix and the focus compared to where's the vertex? I mean, that you can get because they're equidistant. So this point right here is your F, your focus. That point right there is obviously your vertex, and this line is your directrix. Okay? So in your equation, you should have y equals, and then when we have a times x minus h squared, and then we had plus k. That's what we call the vertex form, but remember we also saw it in what, like standard form and another form where we changed it to vertex form. So ideally, this is the form you want it in to get your vertex, which will be at hk. Okay? For now, you're just going to want to know that for the focus and the directrix, they're going to be equidistant to that vertex. So whatever the distance is from the vertex to the focus, it's going to be the same from the vertex to the directrix. So if you have 4 units here, it's going to be 4 units there. If the whole thing is 8 units or 10 units, then they're each 5 and 5. Okay? All this other stuff you're going to learn when you get to pre-cal. Okay? It's out there. It's information. Oh, no, there is one thing you do know. The axis of symmetry, we do know, is x equals whatever that h value is of your vertex, right? It's that line of symmetry that goes up the middle. We have learned that, okay? All right, let's open up the ellipse. So on the ellipse, we have 2 equations, right? Depending on which way it's stretched. So if the stretch is what we call horizontal or left to right, we use x minus h squared over a squared plus y minus k squared over b squared equals 1. And that's the ideal form. Some of them we saw where it wasn't equal to 1 and you would have to divide by everything to get it into that form. But basically, this form is great, okay? So our center is where? HK. Just like it was up there with the circle, right? Just like it was with the vertex, okay? So in order to find the vertex and the vertex, we'll put a V here and a V here, you're gonna count it. And so that it's always gonna be the longer stretch. The co-vertex, which we'll put a CV and a CV, you're gonna count it out and it's gonna be the shorter. Okay? To get the focus, we use C squared equals A squared minus B squared, right? And we always took the larger number first, so you wouldn't get a negative answer. So just in parentheses, write down here, A is greater than B. So you remember to take the larger number squared minus the smaller number squared, and then you go back to your graph and you count it. You count it from the center, okay? All right, this little point in here, we'll put a little F. That's where your focus ends up being on an ellipse, all right? Now, if you have the vertical stretch, this becomes your vertice and your vertice. This becomes your co-vertice and your co-vertice. Your F's still in here. And then your equation looks slightly different. It's going to be y minus k squared over, y minus k squared over a squared plus x minus h quantity squared over b squared. And then all this other stuff is the same as it is for the horizontal stuff, so I'm not going to make you write it again. Yes. Yes. Thank you. Yes, it is equal to 1. All right? What's the difference on the equation on the hyperbola?
Different signs.
Right? Instead of being a plus right there, you're going to get a what? The minus. Okay? So when you open it up, we're going to write x minus h squared over a squared minus the y minus k squared over b squared. Don't forget the equals 1. And then it flips over here too. So y minus k squared over a squared minus x minus h squared over b squared equals 1. And your center is still where? HK. Oop. Your vertex, once you've found where your center's at, it's nice when it's at 0, 0, but when it's not at 0, 0, always count from the center to where your vertex is going to be. This on the hyperbola, your focus is going to be at c squared equals a squared plus b squared. And this one, it technically doesn't matter which one you plug in first, right? Because order operations, you'd get the same number. And then your asymptotes, there is an equation, and when you get to pre-calc and calculus, they're going to teach it to you. But for now, we're just going to draw corner to corner. Right? How I had you take your ruler, your student ID, and just draw in those asymptotes. Okay? And then determine whether your hyperbola opens left and right or up and down. Okay? So this is like a quick little something for you to look at.